Science, the book definition, is the intellectual and practical activity surrounding the systematic study of the structure and behavior of the physical and natural world through observation and experimentation. Well, what that all boils down to is the use of experimentation and observation to study the world around us. That's what science is, simply said. Well, if we go way, way back and think about who were the first scientists to use experimentation and to observe the world around them, who do you think it would be? It may surprise you to find out that they were artists. Of course they were, because the very first painters, the cave painters that we find all around Europe, these very first painters had to make their own paints. They blended their own pigments with binders using vegetable plant extracts. They used charcoal, hematite. For over 70,000 years, people have been taking the available materials around them and blending them into useful concoctions, demonstrating that they indeed had an understanding of the basic structure and behavior of the materials. Well, this continued for many, many thousands of years until one day some artists began to say, well, Luigi's a much better artist than I am, but I make the finest pigments in the country. So some artists decided they would start making pigments and supplying them to artists, or making dyes and supplying them to clothiers. Because people making clothing and art, they needed pigment because people love color and were attracted to color. So this began the beginning of the chemical industry, when people began specializing in supplying these materials to the artists and the clothes makers. A couple examples are royal purple of imperial Rome, or used to make the holy gowns for the Jewish clerics. This was made by taking an extract from a predatory sea snail. This extract was actually colorless, but when clothing was dipped in it, it was laid out in the sunlight, the sun would react with it and cause it to form a color-fast blue dye that was highly valued and extremely expensive. Now, to go with a little more lowbrow example of what was used, India yellow pigment's been used since ancient time in the Far East. They would feed camels turmeric, and they would collect the urine from these camels and condense it down and dry it down into a very stable yellow pigment that was used for a wide range of coloration uses. The very first synthetic pigment ever was invented by the Egyptians over 4,500 years ago. Egyptian blue pigment was used at the time when they were building the Great Sphinx and the Great Pyramid. It's used to decorate the walls of Egypt and was used even to paint their statues. Now imagine you were the first guy to think about, all I have to do is mix a little copper ore with a little calcium carbonate, some crushed up quartz, and throw in some plant ash and heat it up to 1,000 degrees, and I am going to be a very rich person with a high place in society. Because these things were so highly valued, it really made people want to come up with new kinds of colorants and new pigments. So there remained a very tight linkage between science, art, and color that drove innovation literally for thousands of years. In fact, Leonardo da Vinci made a famous statement: those who devote themselves to artistic practices without science are like sailors who put out to sea without a rudder or a compass and can never be certain of where they are going. Now let's fast forward to 1828. When Jean-Baptiste Gamet won the French prize of 6,000 francs for developing a synthetic ultramarine blue. Well, that was about $25,000 back in the day. And ultramarine blue was made from grinding a semi-precious stone, so it was extraordinarily expensive and highly prized. In fact, it would only be used for the highest art. For instance, coloring the Virgin's robe. It was so valuable, more expensive than gold. And Gamet's innovation, he was able to create the synthetic version that was highly stable, and he reduced the price from $20,000 a pound down to $1,600 a pound. And here's a quote from one of my favorite books, The Bright Earth by Philippe Ball. The modern chemical industry was spawned and nurtured by a demand for color. And you can see by the famous blue city of India, people want to surround themselves with color. They enjoy that, and they're willing to pay for that. And that alone really drove chemical industries forward. But then people began to notice the obvious success and commercial value that they could get by utilizing science. And it drove curious individuals to find practical ways to harness science and use it to create even more innovations. Alchemists were actually the proto-scientists to modern science. Alchemists developed the notion of theory. They did experimentation. They developed technical terminology. They even created basic laboratory techniques and methods that walking through a modern day laboratory you would find recognizable from the work of the alchemist. So many, many people contributed to the development and the growth of science. In fact, from 1000 AD, Alhazen, who was considered the first scientist, up into the 1600s with giants like Newton, Galileo, and Roger Bacon. All of these people contributed to the development of science, and all of these ideas came together until eventually we came up with what's called the scientific method. So what I'd like to do is spend a moment and explain to you what the scientific method is, because that method is responsible for many, if not most, of the innovations we see around us today. And the technology that we all use and enjoy is actually derived from the scientific method. The scientific method is a series of steps that scientists take to acquire information about the natural world. And here's the key: through rational testing. Rational testing, there was lots of testing that was probably not so rational, especially by the alchemists. But we were able to distill that down and come up with a method for utilizing rational testing so we can better understand the world around us. In the scientific method, the first thing you do is you ask a question or you pose a problem that you want to solve. Once you understand what you're looking for, then you perform lots of background research to find out what's already known about that problem or that question. Once you've done your background research, you develop a hypothesis, which tells you what you think you're going to find or what you think may be the actual facts, but you won't know until you actually do experiments to test your hypothesis, find out if you're correct. After you analyze the data and develop the conclusions, you're not done, because the scientific method requires you to compare your hypothesis to your final results. And in the end, after you've done all this, if your hypothesis matches your final results, you get a eureka moment and you get your innovation. But then again, maybe not. Maybe you get a surprising answer that doesn't fit with your initial thoughts. And the scientific method then allows you to go back and repeat the process again and learn the information that you need to know so that you can finally answer that question and solve that problem. Through the scientific method, we've been able to derive great benefits for society, and I think this will simply continue because the method has been so highly successful.